Hello and welcome to another important and exciting discussion on motion. And in the last class, we had seen that the acceleration A is equal to the change of velocity divided by time. So we just write that down because we need it today again. So it is change in velocity divided by time. So that is the acceleration of an object. And saying so, we have to discuss more on this topic as we had said in the last class. So what is the change in velocity? The change in velocity is actually the difference between the final velocity of the body and the initial velocity of the body. So change in velocity is actually equal to the final velocity minus the initial velocity of the body, right? So now hence we can put down acceleration in the following manner. Then we can say that the acceleration is actually equal to the change in velocity. So the change in velocity is written in this way. We can say that it is actually final velocity minus the initial velocity, and that we have to divide by the time interval of the body. That means the time taken by the body to for that change in velocity. Now what we actually mean by this final velocity and initial velocity, suppose we have an object. We had seen in the last class some examples and we are going to see them again now. Suppose we have an object and let the initial velocity of the object, means the time when we have started watching this object, that velocity let it be 10 meter per second. So that is the initial velocity of the object when we have started watching it, and say after some time, say after 2 seconds or so, its velocity has changed and now the new velocity of the body is something much different. And let us say that the new velocity of the body is about 20 meter per second. So there has been a change in the velocity, and we had seen in the last class that we can calculate the acceleration from this. So what do we have to do? We have to subtract the initial velocity from the final velocity. That is, we have to subtract 10 from 20 and we get 10 as the change in velocity divided by the time, which is 2 seconds, and we'll get the acceleration. Okay, now let us use some symbols for these things. Let us call this initial velocity, which the body was actually traveling when we started watching it. That is the initial velocity. Let us call it u, and let us call the final velocity of the body as v, and we already call the time as t. The acceleration has already been taken to be a. So if we replace these terms over here with these symbols, what we actually get in this, instead of this, what we actually get is a is equal to final velocity is v, so we can write v, and then minus initial velocity is u, so u divided by time, which is t. So that can be taken as a formula for calculating the acceleration of the body in non-uniform motion. Now if we multiply this t with a over here, we get at, and on the right hand side we have that v minus u. Okay, and if we take this u on the other side, which is actually a negative value, if we take it on the other side, becomes a positive value, and then we have this at over here and plus this u which is coming from the other side, and that will be equal to v. So this thing can also be written as, it can be written in this way, it can be written as v equal to u plus at. Now this relation that we are writing over here, this is an important relation, and it is called the first equation of motion. And actually you have to memorize this. It's very important. It is important for solving questions. So it is the first equation of motion. Okay. Please keep in mind that it is V is equal to U plus AT. So here we are dealing with four quantities. We are dealing with the initial and final velocities, and we are dealing with acceleration and time taken. So let's take a quick example. Suppose a body starts from rest. So it starts from rest. That means its initial velocity U is 0. Okay. And in time t equal to 5 seconds, it is traveling with an acceleration of say 2 meter per second squared. So these are the things that are known to us. And suppose we have been asked to calculate what would be the velocity of the body after the end of this time interval, and that is after the end of 5 seconds. So what will be V after 5 seconds? So in order to calculate this, we can take the help of this first equation of motion, and the first equation of motion can help us in this way. We can say that according to first equation of motion, we have V equal to U plus AT, and hence V equal to, instead of U, we can put down the value of U, which is 0, plus A, the value of A is 2, and then the value of T, the value of T is 5. So 2 times 5, and that will give us the value of the final velocity, which is obviously 10 meter per second. So in this way, we can use the first equation of motion to calculate the unknown quantity from these four quantities if 3 of them are given to us. So this was a discussion about the first equation of motion. We have 2 more equations of motion coming up. So keep watching and don't forget to revise it again and again. These are quite difficult concepts, and you have to actually put them into your minds very well. So see you very soon. Thank you.